Hi, this is Olajide from CTF Security and welcome to another exciting video on the Hack the Box series. Today, we're going to be tackling a new machine called Checker. Now, as usual, we're going to be approaching this machine from a beginner perspective. That is, we're going to be assuming that we have no previous knowledge about the vulnerability that exists on this machine. So without further ado, let's get started. Welcome back to the channel. As usual, the very first thing we are going to do is to make sure that our host file is properly set up to access this checker machine. So what I'm going to do is I'm going to grab our IP address, and on a new terminal, I can just open up my sc/host file, and we're going to append our IP address together with the checker.htb, which is we're redirecting this IP address to checker.htb. So I'm going to save this, my password, and we can close this. So now we can go to our browser and we can access checker.htb. I think we got something wrong there. Checker.htb. Is that correct? All right, let's check that again. So 10.10.11.56. All right, great. So I think we're good. So we have the checker.htb/login. Okay, so we're going to be following the normal process here. So the very first thing we're going to be doing is we're going to be performing a scan so that we can take a look at the different services that are running on this checker.htb domain. So what we're going to do is to run our first scan. Sorry about that. So let's just go to my HTB directory and let's create a new directory called checker, cd checker. Okay, good. So from here, we can run our basic scan using the nmap, sc for script scan. We can do version scan as well. And then we can put in the domain, which is checker.htb. And I think we're good to go. So we're going to let that run. So while we're looking at that, let's check out the interface for the checker.htb. So we can see that this is actually BookStack application. And we can take a look at the webalizer to see what kind of technology we're dealing with. Of course, we have PHP language. We also have the BookStack as the documentation tool. We have JavaScript, we have MySQL database, we have some web framework like Laravel and the others. So we're just going to go do away with that for now. So while we're waiting for the scan, let's take a look at what we have on the view page source here. Okay, so you can see, as usual, basic HTML with some meta tags. We have our styling, we have the body of the page, and what else did we have? What else do we have? Some div tag, we have form, then what else? I think that is pretty much everything that we have on this page currently. So we also have a script source pointing to checker.htb dist app.js version 23.10.20. This might actually be of help to us later on. So I'm just going to leave that the way it is. So let's check the status of our scan. Of course, we have our scan, and it happens that we have about 3 ports open. We have the port 22, we have the port 80 and we have the port 8080. So I'm just going to copy the result of this scan, copy, and let's take this to our Notion page. So the very first thing we did was, let's call this one H2. So nmap scan. And this is the result of our nmap scan. So we can see that we have access to port 8080 and we have access to port 80. And it happens that this particular BookStack is running on port 80. I don't know why I keep getting that. Okay, so let's say /login. Okay, great. So we can see that we're dealing with port 80. And let's see what is running on port 8080. Okay, great. So we have another application running on port 8080, which happens to be Teampass. So now we're going to just fall back to our report here. Let's call this one H2 again. Found 2 applications. So we found the first one was BookStack, and the second was Teampass. So we have no idea what this 2 application is. So let's just quickly do some Google search. So we can say, okay, BookStack application. So let's get a feel of what these applications are. Teampass application. Okay, so we have something on BookStack. I'm going to open that. And this one is still loading. Keeper security, Teampass. I think this is what we're dealing with, but I'm not really sure. Okay, so let's see this logo. So it's not really the same thing. But if we're able to get the version, we can be sure that we're dealing with the same application. So I'm thinking this Teampass is more of like a password manager. And let's see what this BookStack is all about. So for the BookStack, it says BookStack is a simple, self-hosted, easy-to-use platform for organizing and storing information. Okay, sounds nice. It has a GitHub and it has a demo page as well as an install button. So I'm going to click on GitHub to see what this application has on the GitHub. Okay. We have the BookStack. We have the documentation, which we can go through. But currently now we have a few information to work with. So we're going to stick with the application for now. So since we found the first one, which is the BookStack, and there's really not much information here. Let me just access it here. So let's say we have checker on port 80 /login. That happens to be the home page for the BookStack. So we can start to actually see if admin, and we can try to log in. So we have wrong credentials. So we can try to start brute forcing, but that would take a very long time, and I don't think that is going to get us anywhere on this machine. So what we're going to do is just stick around and just pause for a moment on this BookStack application and try to see what we can find on the Teampass section. So for the Teampass, as usual, I'm going to view the page source. And I think we have much thing here than the one for the BookStack. So we have a lot of JavaScript or code. We have, what else do we have? Let me just scroll down. So you can actually see them, scripts. So if I strip off the view source, so what we can do is inspect. And the very first thing I want to do is I need to know what kind of version of Teampass I'm dealing with. So this is still BookStack. That's surprising. Let me just refresh. So I'm going to load that again. Still BookStack. Okay. So what I'm going to do is I have this documentation. Let me just close this. Scripts. So I have this JavaScript we can use to actually find versions embedded in source code. So since we have a lot to deal with regarding the source page for this Teampass, so we can actually use JavaScript to extract the versions from the page here, if it exists at all. So if you take a look at it, so I'm going to just do find on this page. Let's call this version. Of course, if you need this, just indicate in the comment section, and I can actually share this or post this on the GitHub page for easy accessibility, or for you to easily access this particular JavaScript. So we can actually merge functions. We can instruct email, we can extract emails, for example. We can merge versions as well. So I think I marked this with works better, but let's see what that is going to give us. Sorry about that. I'm going to copy and let's go back to this. So we're going to go to console. I'm going to execute this JavaScript, and I don't think we found anything. So nothing. So that is on Teampass. How about on BookStack? So on BookStack, we're able to find version 2.23.10.2. So I'm just going to copy that out. And let's go back to checker. So we know that the BookStack is running version 23.10.2. As for the Teampass, what we're going to be doing is trying to check the sorry about that. So what we're going to be doing is we're going to try to see if we can gain access to the Teampass GitHub page. And I think I opened that previously. I don't know if I did. So let's just go with Teampass GitHub. So we have a GitHub page. I'm going to try to access that. And let's see if that is what we are dealing with. Okay, good. So this is the Teampass GitHub page. And you can see some of these files that are within this Teampass application. For example, We have the index.php, we have the error.php, we have things like security.md. So what we're going to do is try to see if we can access any of this file on the application. So let's start with the security.md. So I'm going to just append that to the end of the document. I beg your pardon, to the end of the URL. And you can see the page is not found. Let's see, we also have change. So we're going to leave that for now. We also have readme.md. So I'm going to try to see if we can have the documentation. Copy. Okay, good. So we just discovered a file within the port 8080 for this checker. And it happens to just say Teampass 3. So now we know that we're dealing with Teampass 3. So I'm going to just copy this and we're going to include it here. So we're dealing with Teampass 3. Let me just add 3 here. Okay, cool. And what else do we have? We have some URL. We have Teampass is a collaborative password manager. So I think we got guess right. So it happens that this Teampass is a password manager. And when you scroll down, you can see some of the requirements, dependencies. You can also see documentations. What else do we have? So it says read documentation with a particular URL here. So I'm going to grab this URL and let's try to access it. So this is actually where all our documentation can be found. So we're dealing with GitHub. So I think it's taking me back to the URL we have here, which is nice. Okay, so it took us back to the same GitHub repository. So what we can do is, do we have any other interesting file? So we have something called change, I think change log.txt. And it happens that it was modified about 4 months ago. So I'm going to grab that. Let's copy and see, can we access it from the URL here? Oh, yes, we can. And you can see it's also telling us that Teampass is a collaborative password manager. And this is the file we are currently accessing. And it says the author is Neil Laumala. I don't know if I'm pronouncing that correctly. So we have a copyright between 2009 to 2022. So I'm going to take note of that. And let's make sure that we have it down. So the Teampass has this particular copyright between 2009 to 2022. So if we check the actual repository and we try to access the changelog.txt, so let's see what we have there. So we have 2009 to 2025. So meaning this has been updated compared to what we have on our target application, which is interesting. So we could go back a bit on this original repository and try to see. Okay, I think I can Scroll down a bit. Where's the file again? Change log. We could try to access the history of this file. Since it was changed between 2022 to 2005, we can try to access the history. And you can see major commits that has been done to this particular changelog.txt. So we have an update, February 26. We also have version 3.11, which is 2024. So we can actually work with that. So we're looking for a version that corresponds to the application we have, which is the Teampass version we're running on our target system. So we're looking for something between 2009 to 2022. So this happened to fall within that category. Okay, this is 2023. So this does not fall within the category. So we have a commit that was made October 31st. Another one was made October 30. All this happens to be within the range of the 2009 to 2022. We also have others here. So I'm going to just say we are dealing with something within the range of 3.0.0.20, 3.0.0.20. We have 3.0.0.10. So we're going to be looking for our vulnerability within this actual version here. So let's just pick this one. So I'm going to copy, and we're going to do a basic search. So before we do that, so since we're dealing with 3, so assumption is going to be this version. Of course, we can still work with .10, but let's just work with it and see what we're able to get on the internet. So let's go with Teampass vulnerability. Let's put the version in vulnerability. Let's see what we're going to get. Okay, so we have something. Oh my God, I like exploit DB. So you can see that we have a particular vulnerability here, which is SQL injection. That has to do with version 3.0.0.21, and that happened to fall within the range of the version that was released between October to January 2023. That is October 2022 to January 2023. That is in between the 3.0.0.20 and 3.0.0.22. So what we're going to do is actually take a look at the exploit. You can open that up. All right, so the CVE for this exploit is 2023-1545, and we can as well download this, but it happens that we have some Portuguese language here. So what I've done is I have refined this particular exploit into another GitHub repository, which I'm going to share in the description box below. So instead of using this particular exploit, what we're going to be using is from the github.com/r007sec/HTB checker, which is a repository dedicated for this checker ActiveBox machine. And you can see it has a couple of tools within the repository. And currently we're dealing with the Teampass 3.0.0.20, but our version happens to be within the range of 20 to 21. So let's see how this actually works. So this repository contains tools, command, and exploit steps used in solving Hack the Box lab involving Teampass and PHP filter chain vulnerability. It is extended as a reference for others who want to learn and who wants to learn from or reproduce the attack. So you can see how the script actually works. Very simple. So we just need to use the Python to pass in the teampass.py, which is the script itself, and then we pass in our vulnerable URL, and this tends to extract the different hashes of users within the system. So what we're going to do is clone this repository. So let's quickly do that. I'm going to copy and so GitHub, and this is going to clone this particular repository, and we're going to wait for that to complete. All right, good. Let's see what we have. cd HTB checker. And we have our different file here. So for now, we're more concerned about the teampass.py. And let's take a look at what we have. So I'm going to use Sublime teampass.py just to see the script. And you can see some basic importation going on the script. You can see the login format here. We also have the declaring of the data class. For example, we have the base URL as string. We have our arbitrary URL as just a dummy hashed, which is inserted to the string variable. So we have some functions. We have, for example, we have the check API enabled, which means what this function is actually doing is verifying if the API feature is enabled, and if it is not enabled, we see that we get the API feature is not enabled printed out, and if it is actually enabled, it's going to return true. We have the except in the case of error or timeout within the application, which is the error message is going to generate. So we also have another function called the execute SQL, and you can see the inject variable, what it has, the format, which is injecting none, using the union to select the ID, the arbitrary hash, the SQL queries, just different columns within the database from the Teampass user, where login equals to admin within the server. So we're almost certain that we have the admin user within the application. So we have some dummy data as well, like the inject, which is the login. Here we have the password, which is hacked, just a dummy password, API key, just a dummy API key value, and we have our response. So that is just you could just take this script and put it in one of these AI to actually get a clearer understanding of what the entire script is doing. So what I'm just going to do right now is we're going to close it, and we're going to try to run the script with our vulnerable part, which is the checker.htb on port 8080, which is going to appear like this, Python 3. We're going to specify our vulnerable endpoint. For example, if you go to the README, you can see we just have the Python 3, we have the name of the application, and we have the vulnerable endpoint. So let's do that. Python 3, teampass.py, and we have our vulnerable endpoint to be http checker.htb on port 8080. So I'm going to run that, and we're going to wait for our hash to be extracted. Okay, so we found two users on the system, which happens to be admin, and we have Bob. So I'm going to take this here into the checker. So let's say H2 enumerating Teampass vulnerability. So we got 2 users, which is admin and Bob. And what else do we find? We found their credentials. I'm also going to paste their credentials here. So I'm guessing this is some kind of bcrypt encryption, hashing, I beg your pardon. So what I'm going to do is just say what hash is this. So this is a bcrypt hash. So what we're going to do is try to use one of these password or hash cracking tool to see if we can crack this tool hash we just extracted within the system. So in order not to waste much of our time, what we're going to do is ensure we grab this hash. I'm going to copy and can we use Sublime hash? I'm going to paste it in here and make sure we do not have trailing white spaces. So I'm going to make sure I save this, and then we're going to try to use hashcat to crack this. I beg your pardon, use John to crack this. And first we need our word list, which is going to be rocku. So I'm going to locate rocku.txt directory. And there we go. So the next thing I'm going to do is we're going to use John, and we're going to specify the hash name, which is what I just created. And then we're going to specify our word list to be equals to the directory of our word list. So let's actually see if this is going to work. So we got using default input encoding UTF-8, no password hashes was loaded. So we could try to say, okay, let's see cat -a hash. So I think there's issue around here. We're supposed to have dollar symbol as the last character on each of the line, but let's just see what we can do. So we can try to use set to clean this up. We're going to use the so let's see, and then let's run the value again. So you can see all the spaces here has been removed, and let's see what we can do now. We can run the John hash, the word list, and let's see. So our password cracking has started, and we just give this few minutes or seconds to load, depending on how complicated the password is. So you can see it's loaded 2 password hash with 2 different salts, which is bcrypt, blowfish 32/64. So while we're waiting, we're just going to grab a cup of coffee and we'll be back shortly. Okay, so this is awkwardly taking a very long time. So what we're going to do is see, can we use a different tool so both can run simultaneously while we proceed? So what I'm going to do is I'm going to grab this command, and let's see if our AI can just do something for us. So let's say generate an equivalent, don't know if I spell, command to crack this bcrypt hash using hashcat. So I'm not really a fan of hashcat, but let's see if we can generate the equivalent command so that we can run that simultaneously. So it gave us something. So path to our hash file 3200, which tells us that we're doing a bcrypt hash, and then the rockq.txt file. So let's see if that is going to work. Say something to note. You will likely want to add 0 optimized kernel and this workload profile for better performance. Will this work better? Let's just keep it simple. I'm going to open up a new tab. So let's grab that again. So this is just going to be a hash, since we have our hash file in this directory. And let's see what we have. What did it say? So I think the structure of the hash is different. So we might want to copy hash to hashcat hash. So we now have a copy, and so we can do format this in the correct order for hashcat processing. I think here we have admin. So what we're trying to do is probably the John and the hashcat treat file differently. So what we're trying to do here is to make sure we are formatting it using the right hash format. So it says hashcat ignores username like admin and Bob when cracking, so you need the hash itself. Okay, so I guess this is what we are working with now. So what we're going to do is subline hash cat underscore hash, and we can rename this or change the value rather. Save, and let's see if we still get the same message. Sorry about that. Still the same thing, so sorry about that, my bad. Hashcat underscore hash. Still the same error. Can we copy this and see? I don't know why this keeps. Can we just stop this and run it again? I don't know why this keeps giving us much time to crack. Okay, so let's see what we got. It says the error occurred because hashcat expected the bcrypt hash to be in a specific format. The 2y $hash you provided are valid, but hashcat may reject them if they contain extra character like trailing white spaces. I don't think any of them does. So rerun hashcat, correct the hash format, no extra spaces, no username, 1 line per hash. I don't think we have any trailing space. Okay, wait a minute. Hold on. When we extracted the hash, so I don't think there's any dollar symbol. So could that be the issue? Will that be the issue? So I'm going to save and we're going to run again. Okay, so I think we figured it out. And hashcat has started. So you can see initializing backend runtime. And that is going to take a while as well. This is still not taking us anywhere for now. We're just going to allow both to run parallel. So as the cracking is going on, we can check status, we can pause, bypass, checkpoint, finish or quit. So we can use I think S for status. So it's still running. There's a progress. That is not supposed to take this long. So lime hash. Everything is okay. Okay, so I think hashcat has cracked the password. So let me just run this anyway. But you can see it here. One of the password has been cracked, which is the one that ended with TIY. And the password happens to be cheerleader. So if we compare, can we compare the extracted hash? So you can see the extracted hash. So which one end with TIY? TIY. So you can see that is the hash for Bob. So we've been able to crack Bob using the hashcat. So I don't think we need the John cracking terminal anymore. So I'm going to stop that. So what we're going to do is make sure that we have this hash copied out, and we can append this to this, let's call it H2 as usual, call it cracked hash. So this is our password. For Bob. So Bob's password is this. So we have a credential for Bob. We can try to log in this account using the Teampass password manager. So let's go to our interface here, and we can say, let's say we are Bob. Our password happens to be cheerleader. So we can grab that. And the time is going to be 60 minutes, I guess. I'm going to log in. And we're going to leave this just to continue in case we're able to crack the admin password as well. So we got login credential do not correspond. So what could be the problem? What could be the problem? So let's say Bob again. I'm going to copy it again. Cheerleader. Okay, we're in. So I think I copied extra white spaces the first time I did that. So we are in our Teampass application here. So now we have accurate data of what version of Teampass is running on this application. So your attention is required. At least one login attempt with your account has been identified since last successful connection. Please check and report to your local administrator if you are not the author. So I'm just going to cancel that for now. We have 60 minutes access to this dashboard, and you can see that is counting down. Here we can access some information here like the SSH access, BookStack logins. What else can we do? We can view our profiles, and you see that we are Bob. So now we have our email address. So I think we'll be needing this as well. So let's call this H2 Bob profile. So we have Bob email address. What else do we have? We have Bob's API token. So I'm going to also include this. So this one is email, and this is API token. What else do we have? I don't think we have any other information. Timeline, settings. The name is Bob. The last name also is Bob. Let me just go back. We can try to access the password section here. And from this point, we have Bob access. Let's click on it. So Bob has two access, which is the BookStack login, which is the first instance we got here, which is on this check.htb on port 80. And we also have what else? SSH access, which is interesting. So let's try to see if we can view this from the password manager. And for the BookStack login, oh great, so we can actually view this. So I'm going to copy. So for BookStack login, so let's call this one BookStack login. So we have this as Bob's password, and we have his email. Is there any other thing? This is the URL. Okay, so we're going to go back for SSH. We can copy this as well. So let's go to SSH access. I'm going to paste it as usual. So we have two login credentials. We have the BookStack login and we have the SSH. So we might want to attempt to, let's go back here, use SSH since we have port 22 open to log into Bob at checker.htb, and I'm going to grab the password and see where this leads us. I'm going to paste it. So this is actually wrong. There's no password reuse here. So you can see it, it says password. Let me just paste it again to be sure. Let's copy it again. So I'm going to copy this. And we're going to paste it again for the last time. And it says permission denied. So we can't actually log into Bob using this SSH. So what else we can do is try to see if we can log in using this other credential on the BookStack login. So I'm going to grab the password and we're going to head to BookStack. So remember we have Bob at checker.htb. That is the email of Bob. We're going to paste his password, which is a BookStack login password. And we're going to log in. And we have successfully logged into the application here. So Bob created book, Python, Bob deleted book. You can see his recent activity. This is some of the recent draft for Bob. You can see recent updated pages. We can try to access other features. But before we try to see what we are dealing with right here, what we can do is try to see on the Teampass documentation here, or let's just hold on a bit. Let's just proceed with the BookStack. Now, if we move to the BookStack here, we're unable to find what actual version we are still dealing with. So it just says BookStack, but we don't know what actual version this BookStack is. But we can still inspect or view page source as usual. And I'm going to scroll all the way down. And remember, we saw this script the other time, which is the checker.htb dist app.js version 23.10.2. So what we're going to do is to just do a simple Google search, and we're going to use that version. I think I have it here on our documentation. Okay, yeah, so I think this is it. I'm going to copy and we're going to paste. So let's add vulnerability to it. So we see that the BookStack v23.10.2 is vulnerable to LFR, local file read via blind SSRF. And we can just open the link, which is from the fluidattack.com. And this is going to explain more detail about the vulnerability that actually convert SSRF to blind SSRF to LFR, which is local file read. Now you can see this is discovered by Carlos Bello, and we have total summary of the CVE. The CVSS score was 6.5, and this is the CVE ID, which is the 2023-6199. So the BookStack version 23.10.2 allow filtering local files on the server. This is possible because the application is vulnerable to SSRF. So what we're trying to do on this vulnerability exploit is that we are trying to convert a blind SSRF into a local file read, meaning that we are able to extract file or brute force file within the target application instead of making requests directly into the application. So you can see a practical demo here. We even have a video showcasing how this can be done. So this is the actual payload. And if you look at this payload, this is an image source with data image/png content type with base 64. So this is actually a base 64 data, because if we take this data and we take it to Bob Suite, we can actually decode this as base 64. And you can see this is just pointing to a out-of-bound server here trying to load this image.png, I guess. So what we're going to do is, in order not to waste much of our time, we can try to implement this, but I actually did this. I was not getting a request. I didn't know if it is the way I was doing it, but I'll try it anyway. So first thing I want to do is we want to start our collaborator. I can just put this to 5 seconds, I guess. So I'm going to copy the collaborator URL, and we are going to put that in here. So let's call it HTTPS, and we're going to append image.png here, and we're going to encode it as base 64. So this is what we're going to use. So let's go to our request. So what this is trying to say is, if you watch the video, because I'm not going to be playing the video, we're going to try to create a book. And after creating a book, we're going to create a page. And within the page, we're going to start writing, and we're going to save to draft. And when we do this, we're going to capture the request, and then we're going to insert or inject this particular payload into that request to trigger the SSRF. So to practicalize this, you can see that we have our Bob Suite on, and this is the checker ready. So I'm going to right click, add this to scope, and from the proxy, we can filter to show only in scope item. So this was the last request we had. So let's go back into BookStack, and we're going to go to books. We're going to create books. So let's call this one CTF security SSRF to LFR. I'm going to save. Okay, great. So we're going to create a new page, which is where our vulnerable endpoint is. And when we create this new page, so let's just call this payload, the name of the page. And we're going to just try to type random word. Hello, this is CTF. So We can as well try to click around and hopefully the save draft gets triggered. So let's see what we have on the request. Okay, good. So we have the get requests. Okay, yeah, this is it. So we have the put method to this particular endpoint, which is Ajax page 9 save draft. So what I'm going to do is I'm going to send this to repeater, and we're going to just remove these excessive HTTP headers. And you can see it here. This is the page we just created, which is the payload. And we have this HTML formatted data. But if you look at our exploit here, we are inserting this. So this is what we're going to be inserting. So I'm going to copy it up to this point, and we're going to insert it in here. And I'm going to take my encoded Bob collaborator, and I'm going to copy, and let's see what we can do with that on the repeater. So I'm going to append it here. And if we go back to the payload, you can see the closing tag. So let's just add that up here. Great. So we can even do away with this, but I'm just going to leave it. So if we send this is going to insert this image here, and it's supposed to make a request to this particular encoded Bob collaborator. So let's send it and see what we get. So that's taking a while. So we got success here, but let's go to the collaborator. We do not get any response here. So I don't know, probably I'm doing this the wrong way or so. But the good thing is, if you go to the application and you reload, you're going to see the image we just inserted. Let's see if we see that. Okay, good. So this is the broken image we just inserted here, but it's actually not including the SSRF into this particular page here. It's not making the request. So what we can do is, what I can do rather is, we can turn this particular vulnerability, this SSRF, into a local file read, which is where the PHP Oracle filter comes in, or PHP filter Oracle error comes in. And this particular vulnerability was explained. Let's see, I think I have a GitHub repo on that. Okay, still on the repo we're dealing with. Okay, so it's actually called the PHP filter chain here. So I'm going to include a proper documentation about this PHP filter chain Oracle and how it works. But the idea is, we want to use this PHP filter chain Oracle to brute force data using local file read within the server. So if you take a look at this PHP filter Oracle exploits or so, so this vulnerability was posted by synactive.com. And I think it gives a better understanding of how this PHP filter chain file read error-based Oracle works. And you can actually read this to understand it better. This attack method was first disclosed during the Down Under CTF 2022, where HashKitten created a challenge where the player were asked to leak the flag with an infrastructure based on the following Docker files and code snippet. So that is just talking about how this particular exploit came to be. We have some working structure of it. It says, this blog post details the several filter chain tricks involved in this attack, as well as some optimization from the original write-up. Common vulnerable patterns and limits will also be discussed, as the number of affected functions in PHP is wider than expected at first. Finally, a tool was developed to automate the exploitation, and its functionalities will be detailed at the end of this article. So the idea for this attack is the following. Use the icon filter with an encoding increasing, use icon V filter with an encoding increasing the data size exponentially to trigger a memory error. Then use the chunk filter to determine the first character of the file based on the previous error we generated from the icon V. Then use icon V filter again with encoding having different bytes, ordering to swap remaining character with the first one. So this is just the working principle of this. If we try to decrypt our payload, we'll get a better understanding of how this is going to work. So you can read through it to get better understanding. And so what I'm going to do is try to see how it works. And I've inserted this into our repository for the HTB checker application. So what we're going to do is still on our repository here. You can see that we already cloned. Let's go back a bit. So still on the HTB checker repository, we already have the PHP filter chain oracle there, which I've made some modification, which I'm going to be showing you. So the first modification is, let's go into Sublime, or rather cd php filter rather. Why is it empty? So we're going to use the one I have locally here. And we have some dependency which you might want to install. And we have the filter chain oracle exploit. So what I had to change was in the filter chain oracle directory inside the core. So inside the core, we have this brute forcer and we have the requester.py. So we can use Sublime to access the requester.py. So when we need to make modification is where the request is being made. Let's see. Okay, great. So we just need to actually do some encoding here, since our payload is being encoded using the vulnerability we discovered earlier. Where's the vulnerability? I think I've closed that out. So you could see that we had to encode our payload here into base 64, and you can see the image source that was appended to it. So that is exactly what we're doing. So we need to import base 64 and we need to encode, do some little encoding. So we just need to append these 2 lines to the initial code we have, which I'm going to make sure is uploaded to the GitHub. And you have to make sure base 64 is imported into the application. So we're going to execute this. I have the workflow on this GitHub repo here, and you can see the workflow. So we need to change directory to the exploit, and we need to use this format to execute. So let's quickly do that. So let's make sure that we are in the exploit directory. So I'm going to go one step backward. CD one step backward again. Let's just make this full screen. And then we're inside this directory here. So the next thing is to grab this. So what I might want to do is just create a new page and make some modification here. Now, the very first thing is we're running Python 3 against the filter chain oracle exports.py, and then we're setting the target here. So this is going to be our vulnerable part, which is going to be HTTP checker.htb, and this is going to remain. And then we have our file path. So what do we want to extract? We might possibly want to extract etc/host name. Okay, great. So we're going to leave this at put. So we need to proxy it through the BOP. And the vulnerable endpoint is going to be, I beg your pardon, the vulnerable parameter is going to be HTML. Because from the payload, initially, you can see that we are injecting this payload inside the HTML parameter here. So we're also going to, what else? Make sure that from the header, we have our SSRF token imputed. We need our cookies, and we need to send the content type to application x form URL encoded instead of sending the data using the default JSON format. So let's quickly do this. Now we need to set the XCSRF token, and we can get this from the BOP because we've captured the request already. So what is going to be our XCSRF token? So I'm going to copy this, and we're going to insert it in here. So we need to set our cookies value as well. For our cookie value on the XSRF token, we're going to copy this and make sure we insert it here. And for the book, sorry about that. I think I didn't copy this completely. Let's just go do that. Just copy this last line. I think that was where we have issues. Make sure it's complete. Okay, great. So we're going to copy the XSRF again, and let's copy that. Now let's insert the BookStack session. The BookStack section is going to be this. And then I think that's everything. So our extracted data is going to be found in the extracted data.txt. That's practically everything we need, except for the XCSRF token. Let's copy this one more time. And we're going to insert it right here. So I'm going to copy the whole thing, and let's execute. So I'm going to run. Now remember, this is going to be proxied through the burp. I think we have error. Something is wrong. So it says either the file cannot be found, checker.htb. Let's check our documentation. What did we get wrong? The vulnerable part. Oops, sorry about that. That was a silly mistake. For our target, this is going to be our target. So let's modify that here, /target. So I'm going to copy and let's run that again. And let's see. So it's going to go into this target. This is the endpoint it's going to use. And this is the file we're extracting. This is the method we're using, which is a put. And this is the parameter. This is the proxy through the Bob suite. And this is where we are going to log our extracted data. And this is the headers that contain the cookies information about the page. So what we're trying to do is extract the host name of the target machine. So if I'm to do this typically, so since this is not going anywhere, I'm going to stop the hashcat since we can't find the admin. So let's stop the hashcat and say, let's say we want to read, or let's say cat/etc/hosts name. So you can see this is going to point out the name of my host name on the screen. So exactly this is what we're trying to do on the target machine here. Extract this particular file from the machine here and save it into extracted data.txt. And that is taking a while. So while this is going on, let's see if we can enumerate further on the application and see what else we can get. So we're going to go to Teampass. I don't know if we still have a session here. I know we lost our session. So it's going to be Bob. I remember it's cheerleader. That's the password. And I'm going to log in. Okay, great. So if we enumerate further on this Teampass, we can see that we have a documentation here. So I think it's still loading. I don't know why it's not opening. Could it be because we're extracting? So why not get this open in a new tab instead? Okay, great. So you can see we have more documentation about Teampass. Like, for example, we can now get the information about authentications, how the system authenticates, offline mode, encryption involved, import and export, remote servers, a lot of different information, including installation information on this Teampass application. And one thing that will interest me is the authentication. So how does the authentication happen? So it has authentication, it has normal access, and it has secure login with Google two-factor authentication. So it says, let's see what we got. Was that what I was looking for? Okay. It says secure login with Google two-factor authentication. An option permits to enable Google two-factor authentication to complete the initial login process. So, meaning that even if we're trying to probably log into a privileged account on the system, we might be restricted based on this Google two-factor authentication. And we're going to see how that plays out very soon. So, but before we go back there, so you can see based on one reason or the other, we're not able to extract the last byte of this sc/hostname file. So, but we're able to get a better idea that the hostname is checker. So what we're going to do is, can we extract a more interesting file that could give us access to this application? And let's see how we can actually do that. Now, if you go back to let's see, here, let's go back to this SSH. So now you see that the SSH account that we got here was not actually for Bob account, it was actually for reader. So I think I forgot to take note of that. So I could go all the way here and say SSH access is for reader. So let's just paste it here. So I'm guessing the email could be, okay, let's just say reader. An email could be reader at HTB, at checker.htb. Good. So if we try to SSH once again into reader at checker.htb, and we possibly use this password. Remember, we tried with Bob initially and we're not able to access this. So it happens that the reader has access to login using this particular password, but we need a verification code. And from what we discovered earlier, that the Teampass actually use this Google, what is it? It's used this secure login, not this one. Secure login with Google two-factor authentication. So meaning that if we're able to extract the secret key for this two-factor authentication on the server, we might be able to generate our own token to verify our login through the SSH. So one way to figure that out would be to actually ask DeepSeek. So let's ask DeepSeek, what is the path to SSH two-factor, let's just call it SSH Google Authenticator, let's call it default path. So it says that the default path could be the home/.google authenticator. So this is practically saying, since we have the account to be reader, so we are dealing with /home/.google_authenticator. So I'm going to grab this and use it as our path so that we can extract this secret key from the server. So let's call this, let's insert it here. I'm going to save. Sorry, I don't need to save that. So let's copy and see if we get error message or not. Let's see. So the other time we got a message while leaking the host name that says the following local file is being leaked, to show that there's an indication that /sc/hostname can be found on the server. But this time around we got error message, and what it says is this /reader/.google authenticator is either empty or the exploit did not work. So this is more of like a rabbit hole or a dead point. But if we go into the application properly, which is the BookStack, we might get better understanding on how the path to this application works. So let me just show you what I'm talking about. So I'm going to leave this point for now. And if we go to one of these pages here on this Linux Basic, let's go next. All this does not show any paths. Let's go next. Okay, good. So on this particular page here, we can see that this example of this bash script is showing a destination file path here to be backup/home backup. So what we're going to be doing is try to copy this and use as our initial file path before the /home/reader. So I'm going to append that to our file. So let's see what we have on the DeepSeek. Good. So let's append it to the beginning of the file. So now we have /backup/home backup/home/reader/Google authenticator. So I'm going to replace this as the file we want to leak. So once again, I'm going to copy this and we're going to clear screen and let's see what we get. So the following file is leaked, meaning that we have this particular file present on the system. Now, if we're able to extract this secret key, we might be able to actually generate our own token to log in as the reader on the system. So let's quickly do that. We have this particular tool. Let's see. Okay, how to use, I don't know, I think the name is OAuth OTP tool to generate Google Authenticator token using secret key. I can't really remember the name of the application, but I know I have the application. Okay, yeah, I think this is it. So let's verify that we have it. This is still extracting. So let's close this for now. So let's verify we have this tool talking about. Okay, yes, I do have the tool. So let's go ahead and say, okay, so it says you can use it to generate a token. So we're going to use the OAuth and we're going to use the --TOTP and the -B, and then we're going to insert our secret key, which we are currently extracting. So replace your secret key with the base 32 secret key from the Google Authenticator. So let's quickly grab this. So let's call this generating token. So this is what we're going to use. And since it's a one-time thing, we're just going to wait for this to complete so that we have our secret key at hand before we generate the token. So remember, we have the SSH account email, which is the reader@checker.htb. We also have the password. So let's just collect that and make sure we have it handy before this extraction finish. So okay, so this is it. So remember, we need the email. Let me just put it somewhere close. So we need SSH at reader at checker.htb, and we need to use this as the password. Then we're going to generate our token using this particular tool, and then we're going to see if this is going to give us access to the machine. Let's see. So we still have the extraction going on. So it says we're going to be dealing with 32 bits. And I don't think this is this up to 32? Byte, I beg your pardon. Is this up to 32? So since we have next line, so I guess that is the end of the key. So I'm going to copy that. And then let's set the stage for our OAuth tool. Let me just put it in here. Okay, so this would have been better. Placing it here. So we're going to put our secret key here. Sorry about that. That didn't go as planned. Oh, I think I'm having an issue because this is still running. Okay, but that's fine. So what we're going to do is let's start up the SSH. Let's clear the screen. Let's put this one-sided. So SSH reader HTB, and then let's grab our password. And for our verification code, I think we should have our file extracted right now. So let's copy that. And we're going to insert it in here. So let's copy this command and we can execute. So you can see that we just generated our token. We're going to use this to authenticate. And just like that, we are logged into Reader. So you can see, who am I? We are Reader. So the next thing I want to do is Let's see, can we cat /etc/password? This is getting slow to see the users that we have. So we have just the reader account, which is 1000 user ID, and we have possibly root on the machine. So there's no any other user here, which is we're taking a look at IDs that are from 1000 and above. So the next thing we want to do is, can we run sudo on this machine? And you can see that we can run sudo with no password, only with this particular file here. So we might want to check what that file is all about. I can copy and lspals, and we can try to see the kind of permission we have on that file. So you can see the file is owned by root, the group is root, and it has read, write, execute for root. But lucky for us, we'll be able to run this using sudo without a password, according to what our sudo configuration just said. So which is no password here. So we might want to see what is the content of this script. So if I do cat and we can try to enumerate this on DeepSeek, explain this bash script. So we are mainly looking at it. You can see that we have some username declarations. So it's doing a line by line, which is, this is just the shebang. What else do we have? We have source dir name, which is the first variable. So it loads environment variable from the .env file located in the same directory as the script file. So meaning that the can I actually access that variable? Oh, I don't think I would be, but there's no harm in checking anyway. So since it's in the same directory with this file, so we can copy and cd that directory. And let's see, can we see any file there, any environment file? So you can see it here. Can we view the content of that file? Permission denied. So you can see the file is only readable by root, which is interesting. Okay, so let's go back to our analysis. So it reads the .env file located in the same directory as the script. The directory name with the script, which is it gets the directory where the script is stored. Import variable from the .env. So all variables are going to be imported from the .environment file. Then for this next line here, it takes the first argument, which is whatever argument we supply to the script, and pass to the script, sanitize it, and store it in username variable, which we have here. Then outputs the I beg your pardon. Then this outputs the input argument. Then we have the pipe symbol using this tr-dc, which remove all alphanumeric character. Then tr-dc deletes everything except letters and numbers. So which is what this particular part of the script does. And the option, I think we've gone past this. Okay. Option /#checker/checkleak. Then the username we want to check. This is how the script is being executed. Then it executes an external program, checkleak. So we're going to check that very soon. Passing the sanitized username as an argument, likely check if the username has been involved in a password leak. So that is exactly what this application is doing. So let's take a look at how we can test this. So we can actually run the script ls. So since we can use sudo to run it, so we can say sudo check. So this is the binary file it is actually running that the DeepSeek is talking about. Where is it? So it says okay, don't think this is what I was looking for. Okay, it says execute an external program checklick. So this is the checklick it was talking about. This is a checklick it was talking about. So we're going to be executing this particular file with no password. So sudo check underscore leak. That's strange. Okay. I didn't do that correctly. Sudo check underscore leak .sh. So this is not going to ask for password. Still strange. Could it be because I was not using the full part? Okay. So let's do that again. Sudo so let's say Bob. Okay, good. So you can see it, the application has executed, and it says password is leaked using the shared memory with this particular ID. I'm guessing this is a shared memory location, and user will be notified via bob@checker.htb. So this is essentially what this script is going to do. Now, before we can look for a privilege escalation vector, we need to check what the content of this check leak is. But unfortunately for us, I don't think it's a script. Check underscore leak. So it is LSB executable, dynamically linked. So it's not really like a script. We might need to decompile this just for verification purpose. So the output we provided comes with a file command indicate that checklick is a 64-bit Linux executable with debugging symbol included, not stripped. So this is just the property of the file, including the metadata and other information here. So we cannot analyze this particular binary file within this particular machine. So what we need to do is to look for a way to download this to our local machine, and then we can analyze it using the Guidera tool to do our decompiling process to analyze better. So let's see how we can do that. So first thing I want to do is make sure I know what file I'm about to copy out, which is this one. So we're going to use Python 3 to create a Python server, and I'm going to call it http.server, which is going to open by default on 8000. So I can download, let me just move away from this directory here, and we can try to download in here. So wget http checker, which is the machine .htb slash on port 8000 rather slash the name of the file, which is check leak underscore leak. So I think we should be downloading the file. And now if we do ls, you can see our script. I beg your pardon, you can see our binary file. Now we can analyze this file. So to analyze, I could use cd opt. I think I have guidera in this location. cd guidera /guidera. So not forgetting we have our binary file in this directory. No such file as guidera, so that was a mistake. Guidera run. So this is going to open our reverse engineering tool, guidera, which we can use to convert this binary to. So let's just open a new project. Sorry. Open new project. No. Non-shared. So next. Let's just call this YouTube or CTF sec underscore check underscore leak. So let's import file. And you can see here, this is the check leak file in this directory, which we downloaded it to. And then we can select the file for import. And this is just going to take few seconds. Guidera is going to take this binary, chew it, and give us the compiled version of the binary file. And you can see import results. I'm going to click OK. Let's make this big. So it's launching. Check leak has not been analyzed. Would you like to analyze it now? Yes, of course. And these are the various analyzer it's going to use. So I'm just going to use the default. And let's make this full screen. Great. So it's just going to take a few seconds for all the functions to get imputed into the symbol tree here. So I think we're good to go. You can see different functions that we have on this script. For example, we have the main function here. You can see this is the main function of the binary file. And we have write to shell memory as well. We have notify user. We have about 3 to 4 important functions within this check leak binary file. So we're going to start from the main. Let's try to see what is actually happening. We have some variable declaration. I could try to get this to I think Copilot will do better. So let's see, can we use Copilot? So we're just going to give it a few seconds, just a few seconds. So I was actually analyzing this file before. So we're just going to do away with everything within the application. So we created a new file called checker.c, and we're going to be pasting this function to do proper analysis on it. So I'm going to paste the main function first, and we're going to tell Copilot to possibly analyze this function for possible security issues. We can as well paste other function as well. So let's go to Guidera. So we have the notify. It's the notify user function. I'm going to paste it as well. So we also have, what other function do we have? Main, extracted main, notify function, trim. Does trim really have anything? Don't think so. Okay, write to shell memory. This might probably be interesting. I'm going to paste it here. We also have, what else do we have? I think there's one more. This doesn't look interesting. Let's see. Do you have any other important function? Okay, fetch hash from DB. Okay, so this one checks the bcrypt in the file. Then this one clear the shell memory. Okay. Fetch hash from the DB. So there's a connection between fetching of the hash and the MySQL database. So what I'm going to do is copy this as well, and let's make it the third function on the Copilot. So let's try to see. So we can see SQL injection. What else can we see? Select password from Teampass user where login is this. So I think it has to do with this parameter 5. So if we're able to control this parameter 5, which could be the username, I guess. So it says if parameter 5, the username is user controlled and not sanitized, this is vulnerable to SQL injection. Attacker could supply username like Bob or 1 = 1 to manipulate the query. Okay. Let's see. We are also on save string copy, potential null dereferencing. What else do we have? Error handling. So I think this is just analyzing the main function. So let's see. Main function. Could that be just the main function? Where's this database connection here? So let's see this notify. Since there's a connection here on this notify, so I'm going to highlight this, and I'm going to scroll all the way down to the end. That's getting too much. Okay, I think this is the end. So analyze the notify user function. So what we did was to highlight the function we wanted to analyze, and we give the instruction in the Copilot chat section. So it says the function is using a prepare statement. So this is like a step-by-step analysis, but I don't just want to waste time, but you can actually do this to see the workflow of the application. But I'm just going to jump straight to security issues in this notify user function. And it says the MySQL command is constructed using unsanitized input from the shared memory UV5, which can be attacker controlled. Example of vulnerable lines. So it says, if we have this MySQL code here, with this param2, param4, and uv5 here. If an attacker injects shell meta character into the hash, arbitrary command can be executed as the user running this function. And we know that the user running the entire script is the reader, but it can actually execute using the sudo privilege because of what we got after running the sudo-l on the machine. So what we can do is to build on this particular vulnerability here, which is this particular command injection vulnerability here. We can use it to escalate our privilege. But before we actually do that, so we need to be able to write to the shared memory before the application executes, so that we can chain our malicious payload to this particular SQL command here. So remember, it says potentially root if run via the sudo. So this might possibly give us access to root on the machine. So if you go back to our repository, we have a payload already, which I have compiled. We also have a step in how you can actually compile it. So let's go into our terminal to see how that is going to work. So let's see ls. Let's go to cd/document/htb. Sorry about that. cd checker, cd HTB checker. So we can have our exploit here. So you can see the compile version, but if you don't want to use the compile version, you can just compile this exploit.c, and just again, you can view what the exploit.c is doing. So this is it, and just like before, we can try to explain what this exploit is doing, just to save us some time. So this exploit program is designed to inject malicious string into the shared memory segment, just like I said earlier. And step-by-step explanation, it read input until shared memory key is found. You can see if you go to the script, you can see what it is checking. So let's look for that. This leak hash detected. Then attached to the shared memory segment. So it converts the extracted key to a number. Now you notice that anytime we run this checker, let me stop this copying. The other time we run the checker, so we got password leak. So this is what it's checking. So it's actually fetching this shared memory key. And if you go back to the analysis, it converts the extracted key to a number. It uses the shell memory get to get the shared memory segment with that key. Then it uses shell memory attachment to attach to the segment. Then the exploit is going to inject a malicious string. So it searches for a line in the shared memory containing leak hash detect. What it will do is it will append the user supplied malicious string from the argument v to the line, which is the argument we supplied, which is the username. Then it's going to print the modified shared memory. So it prints the updated content of the shared memory segment, then detached from the shell memory. So this is what it's going to do. So the purpose and effect, it is to modify the content of the shared memory segment used by the privilege process specifically to inject a malicious payload into the line that will later be processed by that process. Typical use, if the privileged process later read the shared memory and use the injected string in a shell command without sanitization, this can lead to command injection and potentially privilege escalation, which is what we intend to do originally. So this particular exploit is not meant to escalate our privilege, just to inject our malicious code inside the shell memory. So that is just what this is going to do. And the exploit allows an attacker to write arbitrary data into the shell memory segment. Just like I said, a target line containing leaked hash detected to inject malicious payload, then set up the condition for further exploitation, such as command injection. So what this means is that we might need to run the exploit command parallel to this particular script. And you're going to see what I mean shortly. So if we go to the documentation here, so we've already compiled, so I'm going to be using the already compiled data, but if you want to compile yours, you can just run this against the exploits.c, and this is going to generate a compiled version of the exploit code. So we're going to trigger this exploit. First of all, we want to make this variable called pipe. So we want to cat pipe, and we want to use this particular exploit. We want to run this particular exploit, and then we want to run this SQL injection payload, which says it's going to close the quotation, then it's going to use all equals to 1, which is a condition that always evaluates to true. Then if this condition is true, it's going to execute this command here, which is to append this particular file. So it's going to copy the /bin bash /homereader.bash, and it's going to execute this particular command here, which is changing the mod of this particular file. So it's going to change the permission to 4755, which is setting of set UID binary. So you can possibly check this just to verify what that actually means. What permission is this? So 4755 is going to be the set UID permission. So we can as well check, so you can see the suite permission. Before we set the suite permission, we can check the current permission that we have. So let's go in here and let's copy this file. Do we have this file already? We're going to try to cut the file. Oh, that's not what I wanted to do. Ls rather. Not cut. So this was from the previous exploit. So I'm going to clear. So what we're going to do is ls, and what we want to do is, let's go a bit backward. So what we want to do first of all is to make sure we copy this our exploit into the system. So I'm going to use Python 3. I'm going to start a server-m http.server, which is going to serve on port 8000 as usual. And we're going to use the wget to download the file on http my IP address, which is 10.10.15.11 on port 8000 / is 800 and 8000. home/exploit, which is the file we want to download. Permission denied, so we can actually download this to this directory. So I can cd/temp to do that in the temp directory. So let's copy selection, and I'm going to paste, and we've successfully downloaded that. I'm going to change, so this was the previous file I've downloaded. So let's remove the first one. And rename move exploit1 to exploit.1. Sorry, to exploit. We're going to give it permission plus x exploit. Okay, great. So I'm going to also remove previous file pipe. So what we're going to do right now is we're going to be using this command. First of all, we want to make the pipe, and we want to execute this command to set our setUID. Oh, that is not what I intended. So I'm going to copy that again. Just this line. So this is just going to execute, waiting for the next command. And then we're going to use sudo that was wrong. Pipe. So it's done. Now if we do ls-l/home/ or rather, instead of doing that, why not run /home/reader/.bash/p to escalate our privilege to root. And you can see it. Now if I say who am I, we are root. Now we have access to cd/root, cat the root.txt file. So we gain complete access to the entire machine through this command injection privilege escalation. So we can also cat home/reader/ don't know if that's the full part, user.txt, but I'm not sure. Okay, yeah, so that's the full part. So guys, this is the end of today's video. If you've learned one or two things from this video, kindly make sure you like, subscribe, and share. And I'll see you in the next video.